Hello and welcome to a walkthrough on paper 2 higher tier Edexcel GCSE maths. So this is higher tier from June 2019. So it's the first of the two calculator papers. So I'm going to show you how to use a calculator to its full effect, and also for some questions I'll show multiple methods so that if you don't like one method, hopefully the other will be of use. So I'll get straight to it. So let's have a look right away at question 1. So for question 1, we have to solve an inequality, and we're solving 14n greater than 11n plus 6. So for this one, I think it's fairly obvious what to do. What we need to do is to get all the n's onto one side of the inequality. So let's do that. So we've got 14n greater than 11n plus 6. Inequalities work very much the same as equations. What we do to one side, we need to do to the other. So if we subtract 11n from both sides of this inequality, like so, on the left, 14n's take away 11n's, leaves us with 3n, and on this side, the 11n's we've had have now all been taken away, so we're just left with 6. Now we need to leave this in terms of n on its own. So to go from 3n down to just 1n, we can divide that by 3. Remember, any value divided by itself will just give us 1, so 3 divided by 3 leaves us with just 1n. Do the same on this side, divide the 6 by 3, and we get 2. Therefore, n has to be greater than 2. So we're off and running, and I've got the first marks in the bag. Part B is very similar. And the only way this could maybe confuse people is that it's an inequality, but it's got 3 different parts to it. Like I said about equations, what we do to one side we need to do to the other. It works if there's a middle bit as well. So we want x on its own, so what we can do here is take away that 3 from all parts of this inequality. And if we do that, on the left, minus 2 minus another 3 gives us minus 5. Keep the symbols exactly the same. In the middle, we're left with just x, because we had 3, we've taken 3 away. And on this side over here, 4 minus 3 gives us just 1. The final step we have now is to use this number line to record what this means. So the end number's minus 5, and so what we can do first of all is just put a circle above minus 5. And we also have a value at 1, so in the same way we can put a circle above 1. Now, less than or equal to 1 means we can also include the value 1. So what we need to do here is colour in this final circle. And the way I think about whether to know if you colour it in or not is to think about ink. This symbol here on your exam paper requires more ink than this symbol because of this line under it. In the same way, a filled in circle takes more ink than a hollow circle. So we'll leave this one as hollow by the minus 5. We fill in this circle by the 1, and we need to do a line connecting both circles to tell us the range of allowed values that x can take. So x can be anything in the black, it can't be in the hollow, so it needs to be greater than minus 5, all the way up to and including 1. That's question 1 sorted. Question 2, drawing a graph of y equals 2x minus 3 from a range of x from minus 2 to 4. There's 2 main ways of doing this. The first method I want to show you is probably what your teachers told you to do. This is a standard method and probably the safest. Just construct a table of values for x and y. If we do that, just need to think about what x is running from. X is going all the way from minus 2 up to 4. So fill in these values, and then we can just substitute in our values of x into this expression to work out the corresponding values of y. So at the bottom here, when x is minus 2, y is going to be 2 times minus 2 minus 3. If you try that on your calculator, you'd get minus 7. The next one, we're going to have 2 times minus 1 minus 3. 2 times minus 1 is minus 2, minus another 3 gives us minus 5. When x is 0, this is probably the easiest one. 2 lots of nothing is nothing. Minus 3 gives us minus 3. And by now you should establish a pattern. The values of y are going up in 2s each time. So this next one, just keep on adding 2s. Minus 3 plus 2 is minus 1. Minus 1 plus 2 is 1. Then 3. Then finally up here, 5. So what we can do now is to plot these values in. So we've got minus 2 and 7 down here. Minus 1 and 5. 0 and minus 3. 1 minus 1. Pardon me. 2 and 1. 3 and 3. And last but not least, 4 and 5. And then if you've done it right, you should see this is a straight line going through all of these points. And thank goodness it works, which proves that we've done the points correctly. And that's the question done. The second way of doing it will be just to find any 2 points. The key here is to spot that this is going to be a straight line graph. And that's because it's in the form y equals mx plus c. So power of y is 1, power of x is 1. There's no x squared or anything like this. The standard form of a straight line graph is y equals mx plus c, where m and c are just numbers. Because this fits in with that pattern, we should know it's going to be a straight line. And all you need to make a straight line is just any 2 points. So we could pick just any 2 values. So for example, pick 2 points. And the points you pick are entirely your choice. I'm going to pick x equals 0. If we pop x equals 0 into this, y equals 2 times 0 minus 3. So we get when x is 0, y is minus 3. So that's this point down here. I'm now going to pick another point. What I would suggest we do is to pick a point which isn't too close to the one we've just done. Leave yourself enough space. The more space you have between your 2 points, the clearer it is what your straight line is going to look like. So next I'm going to pick x is 4 actually. So when x equals 4, y will be 2 times 4, 8, minus 3, which is 5. So we found ourselves another point. 4 along, 5 up. There we go. Then all that remains to be done is to do a straight line through both those points and extend it so that we go through the full required range of x from minus 2 to 4. So do a line through the points and extend it beyond. That's question 2. Question 3, we've got Hannah here planning a day trip for 195 students. She asks a sample of 30 students where they want to go. Each student chooses just one place. This table shows information about her results. We're asked here to work out how many of the 195 students you think will want to go to the theme park. So looking at this table here, theme park, 10 students said they'd like to go to the theme park out of 30, because 30 students in total were asked. So we can say 10 out of 30 students chose the theme park. Oops, I missed a word. 10 out of, I mean to say. Now, if 10 out of 30 students chose a theme park, we can put these 2 numbers into a fraction. Out of just is like the fraction line. Whatever comes after the word of goes at the bottom. The first one goes at the top. So 10 out of 30 students chose a theme park. I'm going to assume here, if this sample is fair, that 10 30ths, which we can simplify down on the calculator, which I'll show you here. So 10 on the top, press a fraction button here, 10 over 30, press equals, we get 1/3. So we can assume, it is an assumption, that 1/3 of students chose the theme park. But we want to work out how many of the 195 students we think will go to the theme park. So based on our assumption that from this sample, a third of students chose the theme park, we can then scale it up from 30 students to 195. So we would estimate that 1/3 of these 195 students would want to go to the theme park if this sample is representative of the total student body, and that ties into question part 2. So 1/3 of 195, we can now calculate this fairly straightforwardly. So 1/3 of works as multiply, 195 gives us 65. So the answer we're going to go for here, is 65 students. Now for part 2. Part 2 says, state any assumption you made and explain how this may affect your answer. So there's a couple of things we could put to answer this question correctly. I'm going to go for and suggest to you put something like this. So I've assumed here that the sample of 30 students is representative of the population of all 195 students. What I mean by representative is that the proportion of different items in the sample very closely reflects the proportions of different items in the entire population. So, for example, if there was an even mix of boys and girls in this 195 students, a representative sample of 30 should be about 15 boys and 15 girls. If not, the sample is not necessarily representative. Then in terms of how it might affect the answer, if it's not representative, my answer is likely to be wrong. If this sample is skewed and you've just asked a certain grouping of people and not taken this sample from throughout the population, it can't be guaranteed that the sample will accurately reflect the whole population that it's meant to be representing. Question 4 is a volume question. So we have a container here. It's in the shape of a cuboid, and we're told the container is 2/3 full of water. We're then told that a cup holds 275 mils of water. We need to work out the greatest number of cups that can be completely filled with water from the container. So, first of all, we need to recall how to work out the volume of a cuboid. So the volume of any cuboid, a cuboid is a shoebox sort of shape, which this one is. It's always going to be the length multiplied by the width multiplied by the height. So do we have all this information? Actually, yes, we do. We've got the length from here to here. That length is 30. Do we know the width? Yes, we do. The width this way is 6, and we also know the height. Going up, we have 19. So it's just a case of multiplying these three numbers together, and we'll have our answer for the volume, and this will give us a method mark. So 30 multiplied by 6 multiplied by 19. So if we do this now, we've got 30 times 6 times 19. This gives us 3,420. So 3,420 cubic centimetres. But this container is only 2/3 full of water. So we're only using 2/3 of this volume. So the actual water held in the container is only going to be 2/3 of that number. So we want to work out 2/3 of 3,420. So we'll do that and see what we get. So bring the calculator up, and then we're going to times this answer we had here, 3420. Going to multiply that by 2/3. We want 2/3 of that volume, which gives us 2,280. So our 2/3 volume is 2,280 cubic centimetres. Now at this point there's a potential to be confused, because this cup, each cup has 275 millilitres of water, but the volume's in centimetres cubed. What we need to know is an important fact that relates capacity and volume. And the fact is that each milliliter is actually defined, it's identical to, you could say, identity symbol, 1 cubic centimetre. And so we're going to use this to get the units into the same thing. And so 2,280 cubic centimetres is one and the same as 2,280 millilitres. So the number of cups that are 275 millilitres each that can be filled from 280 is going to be 2,280 divided by this 275. So we just do this on the calculator, see what we end up with. Oops. So 2,280 divided by 275. We get 8.290 recurring. That 9 and the 0, the dot above, means 9090 going on forever. So we get 8, I'm not thinking, 0.2909090 and so on. So this means 8 and a bit cups essentially. But the question is, how many cups can be completely filled? And so there's 8 and about 29% of another cup. So that means 8 complete cups can be filled. So therefore 8 cups is the maximum. 8 filled cups. And that's all we need to do for question number 4. So moving on to question 5. Question 5, ABC we're told is a right-angled triangle. We're now asked to calculate the length of AB. So AB means from A down to B. Give your answer to 2 decimal places. This is a standard, basic, if you like, trigonometry question. If it's a right-angled triangle, we know an angle and a side. We want another side. We should know by now this silly-sounding phrase, SOHCAHTOA. So if we bring this up now, you'll hopefully remember these triangles. SOHCAHTOA. So first of all, what I'd always suggest we do is we label each side. So the angle we know, we think about the side opposite to the angle in question. Opposite to this angle we know, which is 38. We label that O for opposite. The longest side is always the side opposite the right angle. So opposite the right angle is 16. We label that H for hypotenuse. The other side that isn't the opposite or hypotenuse, that's called the adjacent side. So I'm going to leave that big A for adjacent. So we're told here that we want to calculate AB. So AB means the side going from A to B, this side here. So that's the opposite side. So colour in or label O on the SOHCAHTOA triangles. So they occur in these 2 here. We also actually know the hypotenuse. So I'm going to colour in the hypotenuse in green because we know that the hypotenuse we know is 16 centimetres. So I'm going to colour in H for hypotenuse. So we circle the triangle now that includes the side we know, hypotenuse, and the side we want to know, which is AB. And so the most useful triangle is going to be this one here, the SOH triangle, because this is the only one that includes the side we know and the side we want to know. So we're going to be using the SOH triangle. where S, you need to know, stands for sine of the angle in question. So here, the angle in question is this 38-degree one. And so, because we want to know the opposite, we can cover up the opposite here and just see what's left. So the opposite, if we cover this one up, you can just see you've got S and H left together right next to each other. So O equals S times H. So S stands for sine of the angle we know, so that's going to be sine 38, and H is the hypotenuse, which is 16. So if anything we need to do now is use the calculator carefully, and we'll have our answer as we need. So we type in sin 38, and really importantly, close that bracket off, otherwise it'll work out the sine of whatever 38 times 16 is. Whereas actually we want sine of 38, then multiply that by 16, and that gives us an answer. We need it to 2 decimal places of 9.85. So the final answer here is 9.85 centimetres. And that's all there is to it. Question 6 is about Sally's calculator. She used her calculator to work out the value of a number, let's call it y. The answer on her calculator display began at 8.3. We need to complete the error interval for y. All error interval means is the two values, a lower and a higher, in between which a number must lie. So here it's saying y is at least as a bare minimum and can be equal to some number here. Well, if a calculator begins 8.3, that's the smallest number it could possibly be. If you add any other non-zero numbers onto this, it will go bigger. So that's the smallest number the calculator could have been. And the answer would be 8.3 if she just didn't go on beyond the second digit. So 8.3 is the smallest value it could be. It can only be that or bigger. This symbol here means y has to be strictly less than this upper value. So if you think about it, what's the absolute maximum limit? What are we not allowed to have? Well, if we've got 8.3, then obviously on the higher side it could be 8.39. It could even be bigger than 8.39. It could be 8.399. And again, and again, and again. It can go all the way up to, in fact, but not including 8.4. So the upper limit is 8.4. And you might be thinking, yeah, but if it begins 8.3, then it can't be 8.4. But this is entirely the point. That's why 8.4 is the smallest absolute maximum limit. We're saying here y can't be actually equal to 8.4, but it can be anything as close as you like to it without being it. So y is at least 8.3 and has to be less than 8.4. This range here from 8.3 all the way to 8.4, but not including it, includes everything 8.3 all the way up to 8.4, which is what the calculator's display has to be. So, question 7. Question 7, I'm going to show you one of two ways of doing this. The first method is going to be a bar model. So we've got £360 shared between Abby, Ben, Chloe and Dinesh. And how nice, it goes A, B, C and D. So the ratio of amounts Abby gets to Ben gets is 2 to 7. So let's begin by thinking of this. So let's bring up Abby, Ben, Chloe, Dinesh. As I've said, the ratio of Abby's amount to Ben's amount is 2 lots to 7 lots. Abby's mentioned before Ben, so this 2 relates to Abby, the 7 to Ben. this means for every 2 lots of money Abby gets, Ben gets 7 equal lots as well. So we can illustrate this with a bar model where Abby gets 2 pieces, Ben gets 7 pieces. Afterwards, we're told about Chloe and Dinesh. So Chloe and Dinesh each get 1.5 times the amount that Abby gets. Well, Abby gets 2 lots. So if Chloe and Dinesh get 1.5 times of Abby's lot, they're going to each get 1.5 multiplied by Abby's 2 parts. If Abby gets 2 lots, 2 times 1.5, or 1.5 times 2, is 3 parts. So this is saying to us that Chloe and Dinesh get 3 parts each. And so this is the complete bar model. So we want to work out the amount of money that Ben gets. So we're interested in Ben here. So if we look at this complete bar model, which must relate to the absolute total of 360, because all the 360 goes to one of these 4 people, we can see that Ben gets 7 pieces. 1, 2, 3, 4, 5, 6, 7. So Ben gets 7 parts out of a total. Well, how many parts are there altogether? So Ben gets 7 parts. 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 parts in total. So Ben's share, if he gets 7 parts out of 15, he gets 7/15ths of the total amount of money, which is 360. So Ben must get 7/15ths, 7 parts out of the total 15 parts of the £360, which we can work out using our calculating device, otherwise known as a calculator. So 7 over 15 multiplied by 360, that tells us Ben must get £168. And that's using this idea of a bar model, which isn't the only way ratios can be done. I'll show you another way you could think about it. This other way is thinking of it as a table. So the table could look something like this. Okay, so we just fill in, first of all, the total number of parts. So first of all, we're told that the ratio that Abby gets to Ben gets, and obviously it's a spoiler because you've seen method A first, Abby to Ben's is 2 to 7. So Abby gets 2 lots, and Ben gets 7 lots. Then Chloe and Dinesh each get 1.5 times whatever Abby's got. So 2 multiplied by 1.5 is 3, so they each get 3 parts each. So add up the parts. 2 plus 7 plus 3 plus 3. So if I add that together, we get a total of 15 parts. But the actual total amount of money, we were told at the beginning of the question, it's actually £360. So we need to scale this up from 15 up to 360. So what can we multiply 15 by to get up to 360? Well, we can work this out by simply dividing 360 by 15. And if we do that, 360 divided by 15 equals 24. So essentially to go from 15 to 360, we need to multiply by 24. And to keep the proportions correct, we multiply all these values by 24. Now obviously we're only interested in what Ben gets, okay? So we're only interested in Ben's amount, but I can show you the versatility of this method. because we can work out all the amounts now by just simply multiplying each number by 24. So Ben is one we're interested in, obviously. So 7 multiplied by 24 gives us 168, which is the answer we were after. So that's our final answer. Amount of money that Ben gets, and gets 168. But again, we can work out the others as well. So 2 times 24, that's £48. And 3 times 24, that's £72. This is a very versatile method. It's not a bar model, it's a bit more old-fashioned perhaps, but it still works just as good in my humble opinion. Let's have a look now at the next question, question 8. So we need to write 0.00562 in standard form. Standard form means we need a number in between 1 and 10. So we want the first number before the decimal point to be at least 1, but a single digit. So essentially what we're saying here, we need the decimal to actually be in between the 5 and the 6. So in standard form, it would need to be 5.62. Then with standard form, we always need to multiply by 10 to a certain power. And this number here, the power of 10, has to be a whole number. Without a calculator, we can just simply see how many decimal places the decimal is at currently compared to where it needs to be. Right now the decimal is here. We need it in between the 5 and the 6. So to get it to where it needs to be, we need it to be 1, 2, 3 places to the right-hand side. Because this number is less than 1, the 3 relates to a negative power, so it needs to be minus 3. Another way we can think of this is as follows. If you want to write a small number, a number less than 1, in standard form, you simply put the decimal point after the first non-zero number, in this case after the 5. The power of 10 will always be a negative, and the other way you can work out what the negative power is simply by counting the number of leading zeros, which is 1, 2, 3. That's another way you can see that it's going to be a negative 3. I'll also mention how you can do this briefly using a calculator. So, on a calculator, I'll just show you now using the bigger screen. We can press Shift Menu. We now go to number 3, number format. So press number 3 on your calculator. Now standard form on a calculator is given as SCI, that's short for scientific mode. So press 2. You now need to select between 0 and 9. Okay, so what we can do here is notice how many significant figures this number has. How many digits do we have after the leading zeros? We've got 1, 2, 3, 5, and the 6, number 2. So we can press 3, and then we can just type in the number now in terms of how you want it to look. So press 0.00562, then the equals, then press S arrow D, and there you go, it will give it to you in standard form. Now, if you want to get back to the normal mode on the calculator, I'll show you how to do that now. Again, press Shift Menu, number format, option 3, press number 3 for norm. You can now press either 1 or 2. I think the most easy way is option 2. It's a matter of preference. Press option 2, and then you're back to normal mode. Part B, writing this as an ordinary number. I'll show you the method for this, and then I'll show you how to do it even easier on a calculator. When we're multiplying by a power of 10, we can think of a number as looking exactly the same as what it does originally, but the decimal place moves. Essentially, in truth, what's happening is the digits are moving in their place value columns. A lazy, but in my opinion, a valid way of thinking about it is how the decimal point moves. So here's my decimal point. So if we're multiplying a number by a power of 10 which is positive, the power of 10, if it's a whole number, tells us how many places the decimal moves to the right. So that means 3 to the right. So our number becomes 1, 2, 3. 1,452 point nothing, because there's no number after that decimal, so we're just going to have 1452. And on a calculator, I'll show you how to do this. We can simply type in this as it looks. So 1.452. There's a button here that does it as well. I'm going to ignore that. Okay, you can use that. I think it's easier personally to just type it in exactly as it looks. So press times 10, then the power button, and then a 3, press equals, and as you can see we get 1452, which is what I showed you would get if you just did it manually, thinking about the decimal point moving. So that's all there is for question 8. Question 9. Now at this point the questions seem to be getting a bit more tricky. We have a question about circles here. So we're told that the circumference of circle B is 90% of the circumference of circle A. So essentially circle B is a tiny bit smaller than circle A. And first off, we have to find the ratio of the area of circle A to the area of circle B. So I'm just going to start off by showing a diagram of what both these circles might look like. So we've got B here, which is a tiny bit smaller than A. So there's two main ways of doing this. I'm going to show you the advised way last. The first way, though, is I'm going to assume that maybe you're in an exam situation, you're panicking, you're not sure what to do. The worst thing you can do is nothing. This is the second best thing. Just try something. So method A, just make some values up. So what I'm going to say here is let's imagine that the diameter of A is, I don't know, make a number up, say a nice number, go for 10 centimeters. So let's just say that the diameter of A is 10 centimeters. Then the circumference of A, you need to remember the formula for the circumference of a circle, it's pi multiplied by the diameter. So pi times the diameter of A, which is pi times 10, which is 10 pi. Therefore, the circumference of B will be 90% of the circumference of A. So 90% of 10 pi. So here we're just using the idea that the circumference of B is going to be 90% of the circumference of circle A, which, using the numbers we've made up, if I go for diameter of A being 10, then we get this, so 90% of 10 pi. So let's work out what this is going to be. So there is a percentage button on your calculator. You could just use 0.90 for 90%, but I'll show you how to do it. So 90, then we do shift and spun. So 90% of 10 shift pi gives us 9 pi. Therefore, the ratio of circumferences, so circumference of A to the circumference of B that equals 10 pi dot dot 9 pi, which we can cancel the pi's. We have 10 to 9. Now circumference is a unit of length. It's essentially going to be measured in centimeters or meters, and so this is a linear ratio. The area ratio, the ratio of areas of circle A to circle B, will be these values for the linear ratios all squared. So therefore, the area ratio is going to be 10 squared to 9 squared. And that's going to be 100 ... 81. The ratio of the area of circle A to the area of circle B is going to be 100 to 81. Another way we can think of this, without thinking about linear ratios, is just working out the radii. So for example, if we go for the diameter of A is 10, we'd have that therefore diameter of B is going to be 90% of 10, which will be 9 centimeters. Okay, so if we use these here, that the diameter of A is 10, therefore diameter of A is 9, just showing you another way before we move on to the second way of showing you. So just making up the numbers, obviously so diameter of A is 10, that would mean the radius of A would be 5. And the diameter of B, 90% of 10, which is 9, the radius is always half of the diameter, the radius of B would be 4.5. So showing you the other way, the area of A to the area of B would be pi times 5 squared. Remember, area of circle is pi times radius squared, and the area of B would be pi times 4.5 squared. So then if we work this out, pi times 5 squared would be 25 pi. Pi times 4.5 squared, well, what's 4.5 squared? 4.5 to the power 2, whoops, gives us 20.25 or 81 over 4. We can then cancel off the pi's and multiply by 4 to get the values into whole numbers. 25 times 4 is 100, and 81 multiplied by 4 is obviously 81. So whichever way around we do it, the ratio of areas is going to be 100 to 81. Method B, applying directly from the start the linear area volume ratios of similar shapes, we can say this. So the linear ratio now we want it in terms of A and B. So of A to B. Using this, and then the circumference is a linear measure. Circumference of circle B is 90% of the circumference of circle A. And so if we have A as 100%, B will just be 90% of that. In terms of decimals, 100% is 1 unit, 90% is 0.9. So therefore the area ratio of A to B is going to be 1.0.9, but because this is an area, we just simply square both of the linear values in the ratio. So that gives us 1.0.81, and then if we multiply both sides by 100 to get them both into integers, both into natural whole numbers, we again will arrive at 100.81. So just showing you a couple of ways how you can think about that particular question. Part B, again, similar idea here. We've got square E and square F. Square E has sides E centimetres, square F has sides F centimetres. The area of square E is 44% greater than the area of square F. Work out the ratio of E to F. So again, I'll just get the squares drawn out for us. So here they are. And so we've got F with sides F and square E with obviously sides E. So the area of F to the area of E, rather I'll actually say the area of E as a ratio of the area to F. Okay, so the area of E to the area of F is going to be 100%, because the area of E is 100% of itself. So we can write down 100% first of all for the area of E. But obviously, the question says more than that. The question says the area of E is 44% greater than the area of square F. And so if I have this area of square F as being 100%, then the area of E is the same 100% plus an extra 44% on top. So that's the area of E to the area of F, which obviously can be simplified. So 100% plus 44% gives a total of 144%. Then the area of F we can say is 100%. So relative to F, the area of E is 144% of the area of the smaller square F. We can now get these into decimals. So 144%, if we divide by 100, or just type in 144% into the calculator, I'll show you now actually. 144 shift percent equals 1.44. So we have 1.44 to 1. So that's the ratio of E to F as an area. I'm just going to put in brackets here actually, but in terms of numbers, if these numbers were whole numbers, we could write this as 144 to 100. Essentially the percentages without the need for the percentage sign being there. Okay, so just multiplying both sides by 100. We can now work out the linear ratios. So in terms of the area of E to the area of F, we had 144 to 100. Because area units is squared and linear is 1, to go from something squared to something to a power of 1, we just square root. So if we square root both the numbers here, square root the 144 and square root of 100, we will have the linear ratio of E to F. And so we now have 12, because the square root of 144 is 12, square root of 100 is 10, and we can half both of these values to obtain 6.5. So the ratio of E to F is 6.5, and that's our final answer and completes the question. But I will mention something which is worth drawing your attention to. At this stage here, when we realise the area of E to the area of F is 144 to 100, it's worth thinking about what the area of E actually is. The area of E, if we just take these two numbers here, the area of E, because it's a square, is obviously E squared. And the area of square F, because it's a square, is base times height, which is F times F. So that links nicer. So we can think about, because both these are square numbers, what E must be, if E squared gives 144, E must be 12, because 12 squared would give 144, and similarly, F must be 10, because 10 squared gives us this 100, which we need it to be. Question 10. Mary travels to work by train every single day. So the probability that her train will be late on any day is 0.15. We're now asked to complete the probability tree diagram for Thursday and Friday. So the probability of it being late on any day is 0.15. This is a way of saying that the probability never changes of a train being late. So 0.15 chance of being late on Thursday, it'll also be that probability on a Friday. Now there's only two branches for each day because obviously a train is either late or it's not late. It's a binary choice, it's either one or the other. Remember, the sum of all probabilities for any event will always add up to 1. If this one is 0.15, we can work out this one by doing 1 subtract 0.15, which is 0.85. But just to show you, 1 minus 0.15 gives us 0.85. And we could do the same down here as well, 0.15 and 0.85. Then says work out the probability that her train will be late on at least one of these 2 days. So there's two main ways we could do this. So I'm going to split it into 2 different branches here. So I'm going to call it method 1, actually call it method A, and then method B. So think about method A. Probability of her train being late on at least one of these 2 days. That's the same as the probability that it's late just on Thursday, or it could be late just on the Friday, or the third way it could be late at least one of those 2 days is a probability it's late Thursday and Friday. So the chance that it's late on just Thursday. So late on just Thursday means it's late Thursday, but then it's not late Friday. So it's that route here. The chance it's just late on Friday would be it's not late on Thursday, but then is late on Friday. So it's this green route here. Or, of course, it could be late on both days. So the route we'd take on this tree diagram, where it's late both days, would be late on Thursday, and then also late on Friday as well. So there's 3 different branches here, and we can add them together. So late on just Thursday, the numbers we multiply as we go along. So late Thursday and then not late Friday would be 0.15 multiplied by 0.85. Just by multiplying these 2 numbers together. Or, of course, it could be late just Friday. That's 0.85 multiplied by 0.15 multiplying these 2 numbers together. Or, of course, the third way is it's late on Thursday and Friday. So if it's late Thursday and Friday, just colour this one in properly, that's 0.15 times 0.15. So if we sum this, we'll get our answer. So, bit of a long-winded calculation, but we'll get there eventually. So, 0.15 times 0.85. You can include brackets if you like to, or not. I'll just put brackets in to see how it separates out into 3 separate calculations. But brackets aren't needed, strictly speaking. Then plus this one I've done in green, which is 0.85 multiplied by 0.15, or third and final scenario, it's like both days, which is 0.15 multiplied by another 0.15. Press equals, and this comes out at being 0.2775. So that's method A, which is actually the slower way of doing it. Method B is a bit quicker. And so let's think about the scenario where she's late on at least one day. Probability, late at least one day. That's essentially saying that's every single possibility. In probability, everything is a total of 1. This is the same as saying that that's every possibility apart from minus the probability that it's late no days. Late at least one day. The only way it can't be late at least one day is if it's not late Thursday and not late Friday. So what we could do here is just simply work out one probability and subtract that from 1. The probability that it's late on neither Thursday nor Friday would be this root down here, not late on Thursday, and then not late on Friday either. So this is 1 minus 0.85 squared, or 0.85 times 0.85. So we can calculate this. One minus 0.85 times 0.85. And again, unsurprisingly, we get the same value of 0.2775. That's question 10 done. Question 11. This is a cumulative frequency question. So question 11, it says a group frequency table gives information about the times in minutes that 80 office workers take to get to work. Part A, very simply, we need to put this into a cumulative frequency table. Cumulative frequency just means we add up the frequencies as we go along. So the first number is just simply 5. The first number is always the same as the first number in the normal table. Next, the second row is going to be the sum of the first two rows. So the second one is going to be 5 plus 30. 5 plus 30, that's going to give us 35. The next one, we add on 20 to what we just had. So 35 plus another 20 gives us 55. Then we add 15 on. 55 plus 15 gives us 70. And keep going. Plus 8, that gives us 78. And finally, add another 2, gives us 80. So the completed numbers are 5, 35, 55, 70, 78, and 80. Now for part B, it says on the grid, draw a cumulative frequency graph for this information. So all we need to do here is to plot these values accordingly. And we always plot from the ends of these intervals. So we plot from these numbers, never obviously the zeros. So the first one is 20 minutes and a cumulative frequency of 5. So it's 20 along and 5 up. So first of all, plot each point. So 20 along and 5 up is going to be about here. 40 along, 35 up will be roughly here. 60 along, 55 up takes us to approximately there. 80 along, 70 up is here. 178, 100 along, 78 up would be this one here. And the last one, 120 and 80, we've got that one. Now the next thing, and I apologise in advance, I've cheated by doing this in advance, is to try and draw a smooth curve through all of these points. Try and do a smooth curve through them. Now, the saving grace is the mark scheme will allow you, if you struggle terribly with drawing, or you struggle with hand movements, or doing a smooth curve you find a nightmare, they would award you marks if you join these with a straight line. Okay, you could do from point to point with a straight line. That's one option you have if you really hate it. If you can do, though, draw with a smooth curve. So I'm going to try this now, but I pre-apologise here. I'm going to show you after one where I've done it looking much better, because I personally struggle myself. So let's see if I can have a go now at doing this. So a smooth curve through all of these points. Something like that. Now that for me actually isn't too bad. Now you can see here that that's gone slightly wonky, so it's not perfect, but something like that. So here's one I made earlier in case I messed this one up. That was actually better than I thought. Here's my one from earlier. But now I'm going to use this for part B to do part C. So part C, it says use your graph to find an estimate for the percentage of these office staff who took more than 90 minutes to get to work. So the key figure here is 90 minutes. So what we're going to do is we're going to go to 90 and read up. So when we get to the curve, we then go along and read off at that value. So going up and along, I make that to be 74. 74 people took 90 minutes or less, is what that means. Therefore, because there's 80 people in total, 80 minus 74 equals 6 people took over 90 minutes. So 6 people, we need to do this as a percentage, remember. So 6 out of 80 is the proportion that took over 90 minutes. To change from a fraction to a percentage, we multiply by 100. So 6 over 80 multiply by 100. That gives us 7.5%. And again, you may have got 6% or 9% based on how you've drawn your curve. As long as you've drawn your curve carefully and done your best, and evidenced that you've read off at 90 and gone along to get this value here, you would obtain some method marks, likely all, if your answer is close to being 7.5. So that's that question completed. We can now have a look at question 12. Question 12, we've got OAB, which is a sector of a circle, centre O, radius 7 centimetres. The area is 40 cm squared, and we need to calculate the perimeter of the sector, giving the answer correct to 3 significant figures. What I'd say first and foremost is we need to remember what a sector is. A sector is essentially a slice of a circle taken from the middle. So it may well be worth just considering this as a fraction of the full circle. So in dotted red, there's the bit of the circle which is missing, effectively, and we want the bit which is visible, OAB. So we need to work out how much of the circle we have. Is it a third? Is it a quarter? Is it something else? So we need to work out this angle in the middle, which I'm going to label theta. So at this point, we need to recall the formulae for both circumference and area of a circle. Now, circles, circular foods, I'm thinking pies. So there's a few ways you can remember the formula for area and circumference. Here's how I think of it. I think of it in terms of chicken and apple pie. Okay, chicken pie you'd have for main, apple pie would come after for dessert. So If it's baked well, and it's very nice indeed, I'd say that chicken pie's delicious, apple pies are too. I know that's very silly. You don't need to remember it that way. If you struggle to remember which is which, remember C comes before A, chicken pie, you'd have to put an apple pie. Chicken pie is delicious, apple pies are too. And I apologise if you're a vegetarian, you might want to think of this as being a cherry pie instead. I don't know, you can make it whatever you want for C and A, as long as you can remember these formulas. So these are formulas for full circles. Obviously this isn't a full circle, this is just a sector, it's a slice. And so because this is a slice, the area of this, which is 40, is just going to be a fraction of a full circle. So the full circle is pi r squared. The fraction of this full circle, well, in terms of degrees, in terms of angle, a full circle would be 360. Because we've got an angle theta, the fraction of the circle this is, the sector, is theta out of 360. So theta over 360 times pi r squared, that would tell us the area of the sector. Now we know some information here. We know what the area of a sector is. We're told it's 40. We also are told what the radius is. The radius is 7. So we can substitute values in for this. So theta over 360 times pi times the radius squared. Radius is 7, so 7 squared equals 40. So now it's just a case of plugging the numbers into the calculator, rearranging, and our answer should drop out quite nicely. So if we arrange in terms of theta, theta will equal 40, multiply both sides by 360, and then divide by pi times 7 squared. So if we do this, what we'll get, 40 times 360 on top, and on the bottom, shift this button here to get pi times 7 squared, and get 93.5. Now, this isn't our final answer, so I'd give this to more accuracy. So I'm going to write this as 93.54413. 93.54413. Now, the reason I'm doing that is because I don't want to round prematurely. Only round at the very end of a calculation. If you round the middle of a calculation and then multiply or divide, it may bring in some rounding error, which might affect your overall answer. So it's an easy way to lose a mark. To avoid doing that, don't round prematurely. Give your answer in any middle step to at least double the number of significant figures your final answer is going to be given to. If you can, use your full calculator display. So we've worked out what theta is in terms of degrees. Now, the perimeter of this is going to be the length all the way around the outside. So perimeter of OAB, that's going to be 7 plus 7. I can just show you why it's going to be 7 plus 7. So if I were to do quite a thick line in a red colour, in fact I'll have that line going a bit thicker, 7 plus 7 for 2 radiuses, and then also there's going to be this bit around the outside of the circle. There's going to be this arc. It's called an arc, where an arc is essentially a portion of the full circumference. So this is called an arc. From A to B there is an arc. It's a fraction of the full circumference. And so the fraction of the full circumference, again, is going to be this fraction here. So it's going to be theta over 360. But we now know that theta is this 93.54413 and so on. So it's that fraction of a full circle multiplied by the circumference. So the circumference is pi multiplied by 14. The diameter of the circle is always going to be double the radius, double 7, we get 14. And so that's how we come to understand where these values come from. So two lots of 7, 7 plus 7, and this bit here is this fraction of the full circumference. So we can work this out. So fortunately, we've got theta stored. So that's our exact value of theta. So what I'm going to do is put theta on top, so previous answer stored, over 360, multiplied by pi, multiplied by 14. So that's the purple bit, as written here. Then add two lots of 7. So 7 plus this portion. We get 178 over 7. We want it as a decimal, correct to 3 significant figures. So press S arrow D to 3 significant figures, 25.4. So our answer is 25.4 centimetres. So that's question 12 complete. Question 13. Show that 6 plus x plus 5 divided by this fraction simplifies to this here, where a, b, c and d are integers to be found. So first of all, I'm going to have a look at this bit in the big squared brackets. So here, we've got this x plus 5 divided by this fraction. Now, we need to remember how you can change dividing by a fraction into multiplying by another. Dividing by a fraction is the same as multiplying by this fraction flipped. I don't know if your GCSE teacher told you about keep, change, flip. We change the divide to a multiply, we flip this fraction on its head. So that becomes x minus 1 on top now, and on the bottom, x squared plus 3x minus 10. So what we need to do is consider this bottom bit here. So we've got x squared plus 3x minus 10. So will this factorise? Well, we need to think of two numbers which multiply to 3 and multiply to minus 10. So what two numbers could multiply to give minus 10, add up to 3? Those two numbers would be positive 5 and negative 2. So we can factorise this into x plus 5 and x minus 2. And of course, top of this fraction is still x minus 1. So what we could do here, I apologise, just notice what I've done here. This isn't a plus, it's a multiplication. So that should be multiply. Don't know what I was thinking here. So I've got this here multiplied by this fraction. Now what I can do here is I could actually write this as part of the numerator. So that's the same as x plus 5, x minus 1, all over x plus 5, x minus 2, because, like we showed earlier, x plus 5, x minus 2 is a factorised version of this here. Now, comparing top and bottom, numerator and denominator, we should see we have x plus 5 in both. And so because this x plus 5 is a multiple of both the numerator and denominator, we can cancel it on both the top and the bottom. So we're just left with x minus 1 over x minus 2. So what we've shown here is that this yellow bit actually simplifies to, whoops, wrong colour, x minus 1 over x minus 2. So now we can say, therefore, 6 plus this x plus 5 divided by x squared plus 3x minus 10 all over x minus 1. That's the same as 6 plus x minus 1 over x minus 2, because we've just shown that this whole thing here is the same as this. Now, we need to combine this 6 into part of the fraction. Remember, we want to show it's similar, exactly the same as just a fraction, something on top over something on the bottom. So what we could do to this 6 is we could multiply it by x minus 2 over x minus 2. And if we do that, we'll get 6 x minus 2, and because then it'll all be over x minus 2, the 6 and the x minus 2, we can combine it underneath the same denominator. So we can put it all under, so all on top, I mean to say, x minus 2. So we can now expand this bit here. So 6 times x is 6x, 6 times minus 2 is minus 12, then plus x minus 1, all over x minus 2. And finally, if we just simplify this as our final step, on the top, 6x plus x gives us 7x, minus 12 minus another 1 gives us minus 13, and on the bottom we have x minus 2. So the question doesn't say to state what A, B, C and D are. If you'd like to, you absolutely can. Essentially, A is 7, B is 13, C is just 1x, so C is 1, and D is 2. But if you leave it in this form, that's absolutely fine. And so essentially all we need to show here is that this is that. So a bit of a messy question, but as long as you're good with arranging algebra, manipulating and simplifying and expanding, lots of practice, you should find question 13 not too much of a problem. Question 14, we have a speed time graph, and it's showing a car moving from rest. The graph gives information about the speed, v meters per second, of the car, t seconds after it starts to move. So we've got this curve here showing how the speed is varying with time. For 1a, we need to calculate an estimate of the gradient of the graph at t equals 15. Now, gradient of a straight line is just how steep it is. For a curve, the steepness is changing all the way through. So what we need to do is to estimate the steepness at the exact moment the time is 15. So what we need to do here is to get a ruler and try to find a line which just scrapes the curve. Doesn't cross over it, but just touches the point where the time is 15. Okay, and what we're trying to do here is essentially it's called drawing a tangent. We need to draw a tangent line at the point where t is 15. So there's some wriggle room for this. It's not an easy thing to draw, but here's one I made earlier. And as you can see, the point being it just touches when t is 15. It doesn't like cut the curve again here, doesn't cut again at the other side, just touches when t is 15. Now your line might be different to mine, so as long as it's roughly the right slope, that's absolutely fine. Now we need to find the gradient of this tangent. Okay, so the gradient of the tangent, which I'll call t for tangent, is going to be the change in y divided by the change in x. Now, all we need is 2 points on the line to find the gradient. We've got one point here where the time's 15. So, looking at what I think it is here, when the time is 15, just reading off and along, like so, I make that to be 18. So the change in y is 18 minus a different point I need to pick. So I'm going to go for my y-intercept there. Now, from 5 to 10, that's 10 little squares. So each of these little squares must represent 0.5. So that's 5.5, 6, 6.5. So the change in y is 18 minus 6.5. Whereas the change in x, at this point here, the bottom, obviously there, x is 15, and at this point here, x is 0. So change in x is 15 minus 0. Plug this in, and we'll get an estimation of it. So 18 minus 6.5 on top, on the bottom 15 minus 0, 23 over 30, about 0.76. So that would round, because that means 76 recurring. I could give it as either 0.77, or I could give it as an exact fraction. I'm going to give it as an approximated decimal. So 0.77 to 2 decimal places. Now your answer needs to be between 0.6 and 1. So that's quite a range they will allow, but you need to show evidence of drawing a tangent, a straight line which just touches the curve when t is 15. So where that red dot is, you need to evidence you've drawn a tangent there and try to work out the gradient of that straight line tangent. Part 2. Describe what your answer to part 1 represents. Well, if we've got here a speed time graph, then the tangent here, we're working out the change in speed. The change in y is a change in speed, and the change in x, the x-axis, is time. So the rate of change of speed is the acceleration, and so this is representing the acceleration of the car when t is 15 seconds. Part B, we're asked to work out an estimate for the distance the car travels in the first 20 seconds of its journey, and we need to use 4 strips of equal width. Now, if we want to work out an estimate of the distance, the area under a speed time graph tells us an estimate of the distance travelled in the first 20 seconds in this case. Now, if we're using 4 strips of equal width, okay, it's going to be 20 seconds divided by 4. Each strip is going to be 5 seconds wide. So we're going to draw lines at 5 10, 15, and 20, and then we're going to draw diagonal lines joining these vertical bars together. And so what we need to do with a ruler is something that looks a little like this. So 5, 10, 15, 20, and lines joining each strip to the next one. What you need to do as well is to read off the heights of these strips. I need to work out the height of this line here, that one, and that one. And if you read them off correctly, you should find 4, 12, 18, and 20 are the heights of those 4 red vertical lines. So we've now got 4 strips. We need to work out the area of each of those 4 strips, which I've coloured in 4 different colours to make it more visual, like so. So first of all, this yellow strip. This yellow one, I'm hoping you can see quite clearly that this is going to be a triangle. So it's 5 wide, 4 high. So the area of a triangle is half base times height. So for this first yellow one, we're going to have half, I'm just going to call it 0.5, times 5 times 4. That's 10. So this one here is 10. Now this strip here isn't a triangle, nor is it a rectangle, it's a trapezium. So what we need to do is remember the area of trapezium. So trapezium area is half of the 2 parallel sides added together. So I'm going to call it maybe, I don't know, width 1 plus width 2, or height 1 plus height 2 in this case. So it's going to be half height 1 plus height 2 times the width. Now the width of each of these trapezia is going to be 5, obviously. From 5 to 10 is 5, from 10 to 15 is 5, and so on. So for this first green one, I'm going to have a half. Height of this first line is 4. Height of this second line is 12. Then multiply that by the width. Just move that here so you can see the formula. So times that by the width, which is 5. And I have 40. This one. So same formula, but here the height of this first one is 12. That height is 18. So I've got 12 and 18 now. So change that to a 12. I'm going to change the other to an 18. Then multiply by 5. I get 75. And finally this one, that height's 18, that height's 20. So same formula, just alter the numbers. So half of 18 plus 20 and times by 5. I get 95. So the total area, or an estimate of the total area for those first 20 seconds, is going to be these 4 values added together. So we've got 10 plus 40 plus 75 plus 95 and just use a calculator to work this out, and we've got it. So calculator for the final time for question 14. So 10 plus 40 plus 75 plus 95, 220. So it's going to be 220 meters. And that's question 14 finished. Question 15 is making M the subject of a formula. The subject is just what comes first and is on its own. So in this case, currently, F is the subject because it's just one F on its own equals whatever. So we need it to be rearranged so that it's M equals whatever. So what we need to do first of all is to get the m's all together and all on one side. At the minute we've got a fraction here which makes it quite hard to deal with, so what I'd suggest we do is to multiply both sides by m minus 1. So this side over here will become f brackets m minus 1, and on the right hand side, divide by m minus 1 and multiply by m minus 1, that cancels, so we're just left with 3m plus 4. If we now just expand this side, so f times m is fm, f times minus 1 is minus f, then we have 3m plus 4. If we now subtract 3m from both sides at this step, to get all the m's together on the same side, what we'll now have is fm minus 3m minus f equals 4. We just want m's on their own, so what we can do here is add f to both sides. So we've got the m's on one side, f's on the other. So this gives us fm minus 3m equals 4 plus f, or f plus 4. We can now, because all the m's are on the same side, here we can now factorise, because we have m common in both these terms. We have m brackets f minus 3 equals f plus 4. I did the brackets there, apologies, pretty strange. And now, to get the m on its own, we can just simply divide by f minus 3 on both sides. And if we do that, on the right hand side, we'll have f plus 4 all over f minus 3. On the left hand side, we just have m on its own, which is exactly the objective we wanted to attain. So we're done. So m equals f plus 4 all over f minus 3. Question 16 is a question about straight lines. So we've got here a straight line, capital L, has the equation 3y equals 4x plus 7. Now, before I do anything here, I'm just going to suggest we get this into the standard form of a straight line, which is y equals mx plus c. So just 1y equals whatever. So in other words, make y the subject. So if we take this here, we can make y the subject by just dividing both sides by 3. If we do that, we have y on its own equals 4/3 of an x, or 4 over 3x, plus c, the y-axis intersect will be 7 over 3. And that's what L is. So optionally now, it doesn't really matter if you do this or not, but sometimes I think a sketch makes things a bit nicer to see. I'm going to just sketch in line L. So line L, it's got a positive gradient, and it cuts the y-axis at 7/3. So without, making it too accurate a sketch, just to get the idea, I'm going to sketch on line L, a positive gradient, cutting the y-axis up here somewhere. It's going to do something like this. Okay, so that's line L. Now, it says here, there's a point A which has coordinates 3, minus 5. So if I just sketch on 3, minus 5, maybe down here somewhere. So that's A, which is 3, minus 5. I need to find an equation of a straight line, but it's perpendicular to L. Now, perpendicular means at right angles to. And passes through A. So Again, not paying too much attention to the actual coordinates or anything. I'm looking for a sort of line, something like this, where that's going to be 90 degrees. So I want to find an equation of this line here, and don't pay too much attention to the coordinates. Don't be thinking that must be like -2 or -3. It's a sketch, so it might not be perfectly accurate. The point here, the main point is that the equation of the line I'm trying to find, this straight line here, is perpendicular to L. Okay, perpendicular to L means at 90 degrees to it, and that's where we're going to start. If one line is perpendicular to the other, that means the gradient of that line is the negative reciprocal of the other line. So the gradient of line L here was 4/3. Therefore, gradient of the line perpendicular to L is the negative reciprocal of that. So we turn that fraction on its head and change its sign, so it becomes -3/4. So equation of the line which is perpendicular to L again using y equals mx plus c, we're going to have y equals the gradient of this line, which is -3/4 of an x, plus c, which I don't know what it is yet, but I do know that point A passes through this line. So what I can do here is I can substitute A, which is -3 minus 5, into the equation y equals -3/4 x plus c. So when y is -5, x is 3. So -5 equals -3/4 times by x, so -3/4 of 3 plus 3. Therefore c, if I add this to both sides, c will be -5 plus 3/4 times 3. So I can work this out now. So -5 plus 3/4 of 3, and that gives us -11.4. So the equation of this line is y equals -3/4 x minus 11/4. Now it does say here, find an equation of the line, so that's just one equation. So I'm just going to put here, or equivalent, because you could write that same equation in a different way. For example, you could multiply them by 4, and that'd still be effectively the same equation. So if I times both sides by 4, I could also have 4y equals -3x minus 11. That would also be a valid way of writing the equation of that line. Question 17 now. We've got some small cubes and some large cubes in a bag, and some are red and some are yellow. The ratio of small to large is 4.7, and the ratio of red to yellow is 3.5. Part A is a 1-mark question, but it can be quite confusing, this. Explain why the least possible number of cubes in the bag is 88. I'll explain why, which might take a while, because I'll push for the understanding, but the actual answer is actually quite simple. So here, I'm going to say, let the total number of cubes This is just for understanding, okay? You don't need to write this down in your answer. Let total number of cubes equal n, okay? Where n is a whole number, because obviously if you've got cubes, it's either 1 cube, 2 cubes, 3 cubes. The number of cubes is going to have to be a whole number. So first of all, it says here, the ratio of a number of small to a ratio of a number of large cubes is 4.7. Now this here, 4 parts are small, 7 parts are large. That's 11 parts. Therefore, n is divisible by 11. So n's been divided here essentially into 11 separate parts. 4 parts small, 7 parts large. So n, whatever n is for total, must be divisible by 11. And the next bit, as it says, ratio of red to yellow is 3 to 5. And so red and yellow, those two properties are completely separate to the size of the cubes. So this 3 parts and 5 parts are totally unrelated to the 4 and the 7, because these are representing different things. 3 parts plus 5 parts is 8 parts. So therefore, whatever the total number of cubes is, n, it must also be divisible by 8, because if a number of red and yellow is 3.5, that means they can be divided into 3 piles on one side and 5 piles of yellow, so they can be divided into 8 piles as well. So n is also divisible by 8. Okay. It can be divided into a ratio with 8 total parts, which I'm doing in green, or it can be divided into a ratio of 11 parts in total, which is 11. So from these two things, n is divisible by 8 and by 11. Another way of saying that is n is a multiple of 8 and of 11. If something can be divided by 8, that's another way of saying it's in the 8 times table. If something's divisible by 11, that's another fancy way of saying it must be in the 11 times table. So the smallest possible number of cubes must be the smallest number which is in the 8 times table and the 11 times table. And the smallest possible number which is in the 11 times table and the 8 times table is 88. So what I'm saying here is n is the smallest multiple of both 8 and 11. So all this is just sort of extra understanding work. Okay, so all this is just for understanding. The final answer for the 1 mark, this is where the answer comes from, if you like, which you don't need to dwell on too much, it's only 1 mark, but I'd like you to understand it rather than just write it down. The smallest multiple of 8 and 11 is the lowest common multiple of 8 and 11, which is 88. So all you need to put here is 88 is the lowest common multiple of 8 and 11. So all that sort of understanding just for 1 mark. If that was confusing in an exam situation, I'd say probably to leave that question, come back to it at the end. 1 mark, it's not worth exhausting your mental energy on that one. But that's where it comes from. That's why it is 88 as the least. Now part B, it says here all the small cubes are yellow. We need to work out the least possible number of large cubes in the bag. So what we can do here is consider this as two separate ratios and combine them with a bit of thinking. So we've got here ratio of small to large cubes and a separate ratio here, reds to yellows. So we can get a table going for both. And we've called from part A least number of cubes is 88. So if we want the least possible number of large yellow cubes, that will occur when we go for the least number of cubes in total, which is 88. So we're assuming here the total number of cubes is the smallest possible, which is 88. Now first off, we're told that the number of red to the number of yellow is 3 to 5. So 3 red, whoops a daisy, don't know what happened there. So you've got 3 red, 5 yellow, which gives obviously a total. But obviously these 8 parts need to total altogether 88 cubes. So what do I scale this up by to go from 8 to 88? Well, obviously it needs to be scaled, it needs to be multiplied by 11. So what I need to do to scale this to the right quantity is multiply each number in this ratio by 11. So if we do that, we get 33 red cubes and 55 yellow cubes. Now, in terms of these small and large cubes, this is a separate ratio we had before. We're told here the number of small to the number of large is 4 to 7. So for every 4 small, there's 7 large. 4 plus 7 gives us 11 parts. But again, we know the actual total number of cubes is 88. So to go from 11 to 88, which is what it actually is, what do I need to multiply by? Well, I can work this out by doing 88 divided by 11, which is 8. So in this ratio table, I need to multiply by 8. So 4 times 8, 32. 7 times 8 is 56. Now we want to work out the least possible number of large yellow cubes in the bag. Well, here we're told that all the small ones are yellow. Okay, so how many small cubes are there? There's 32 small cubes. So from here, we now know there's 32 small yellow cubes. But from the other ratio table here, there's 55 yellow cubes in total. So if there's 55 yellow cubes altogether, 32 of which are small yellow cubes, then the rest of them must be large yellow cubes. So therefore, we take the 55 total cubes which are yellow, we subtract away the number of those which are the small ones, and what's left, which is 23, must be the number of large yellow cubes. And that's our final answer for question 17. There must be, as a bare minimum, 23 large yellow cubes. Question 18, we've got a circle, and you can probably guess, with it being at the end of the paper, this is going to involve some circle theorems. So we're told that A, B, C and D lie on a circle. and CDE is a straight line. So BA equals BD. In other words, the triangle BAD is isosceles, which we're told by these marks on the sides as well. And we're also told that angle ABD is 40. So work out the size of ADE. ADE is this angle here. So we also need to give a reason for each stage of our working. So first of all, I think we could quite easily work out the angle here and here, because this is an isosceles triangle. So we can say that angle BAD, which is also going to be equal to angle D, which is ADB. That's going to be 180 minus 40, so 140 degrees left for these two angles in the triangle. But because it's isosceles, the base angles are the same. So this angle and this angle will be equal. So we then divide that by 2, and that gives us 70 degrees. So our reason is base angles of an isosceles triangle are equal. Oops. Went a bit strange there. Anyway, base angles of an isosceles triangle are equal. So we can label in that BAD is 70 degrees, and also ADB. So they're both 70, so that will go some way to helping us solve this problem. So I'll just colour code these in as well, because I can, and why not? A bit of colour never hurt anybody, did it? So just popping these in like so. Now, the other thing we need to mention is that A, B, C and D all lie on a circle. So in other words, A, B, C and D, 4 points around the circumference. So what we can say here is that these make a cyclic quadrilateral. And there's a property of cyclic quadrilaterals we need to know. So ABCD is a cyclic quadrilateral. And what we need to remember about cyclic quadrilaterals is that the opposite angles of a cyclic quadrilateral add up to 180 degrees. So we can say that angle BAD plus this angle C, so I'm going to call that BCD, equals 180 degrees. And the reason I'm going to put in brackets, opposite angles of a cyclic quadrilateral add up to 180. Now, we already know what angle BAD is. We worked out that angle BAD was 70 degrees. So, angle BCD, which is this one here, is going to be 180 minus BAD, which is 180 minus 70 therefore. So that's going to be 110 degrees. So we can label in that one's 110. And now we're hopefully, as you can see, getting quite close to solving this problem. So now, again, we can consider BCD as a triangle in its own right. So if you notice again, because we're told that BCB equals CD, and this is another isosceles triangle. So we can now say that the angle B, so I'm going to call that CBD, that's going to equal this one as well, because remember, base angles of an isosceles triangle are always equal. So CDB, that's going to equal 180 minus the 110 from angle at C, divided by 2. If you try that on a calculator if you'd like, you'd find that that gives you 35 degrees. And again, the reason is that base angles of an isosceles triangle are equal. So again, we can add this to our drawing. So little by little, it's piecing together, and we're slowly getting there. And so these two angles here are 35 degrees. And again, I'll colour these in the blue colour so you can see how it's all building up. It's very important as well to, although it's a pain to write so much, to put these explanations in here, because it does say quite clearly to give reasons for each stage of your working. Finally, we can work out ADE, because ADE is now this angle here, which forms a straight line with the 70 and the 35. So ADE, remember, from C to D to E is a straight line. And remember, angles on a straight line add up to 180. So angle ADE is going to be 180 minus this 70 degree angle minus this 35 degree angle. And that gives 75 degrees. And that is our final answer. So again, just to make sure you get all the marks you deserve, I would also include what angle fact you've used here. And of course, the angle fact we've used to obtain that this is 75 degrees is that angles on a straight line add up to 180. And after a lot of writing, we've got ourselves full marks. So that's question 18 done. Let's now have a look at question 19. We're near the end of the paper. Question 19, we have a triangular prism. The base, ABCD, of the prism is a square of side length 15 centimetres. Angle ABE and angle CBE, these two here, are right angles, and angle EAB is 35 degrees. We'll come to that later. M is the point on DA, such that DM to MA is 2 to 3. We need to calculate the size of the angle between EM and the base of the prism, giving our answer correct to 1 decimal place. So let's just pick away at all this information here, step by step. So we're told that M is along DA, such that DM to MA is in the ratio 2 to 3. And so I'm just going to add in the point M. Somewhere here, we can work out the length along DA, that point M is, in a moment. Now, ultimately, we need to work out the size of the angle between EM, so from E to M, is this straight line here, and the base of the prism. So I'm just going to draw in the angle we're trying to find. And so we're trying to find this angle theta here. So theta is between the base, which is from M to B, and M to E. So it's this angle in between the base and M as it rises up to E. We want to give that to 1 decimal place. However, currently, we don't really know anything about this triangle I've colored in green to work out this angle theta. For example, I don't know this EM line here, I don't know the length of that. I don't know the length of EB, and I certainly don't know the length MB. However, if we look closely, we can see that the line MB is a shared side with this triangle from M to A to B. So this triangle in blue shares a side MB with the green triangle. So maybe we can start off by looking at this blue triangle in a bit more depth. So I'm just going to draw it here so we can see it a bit more clearly. So now we can start adding bits of information to this question and start to unravel step by step the problem. So let's now return to this point M. So M is on DA and it splits DA in the ratio 2 to 3. Now the full length of DA is 15 centimetres. Remember, it's a square. And so 2 to 3, that adds up to 5 parts in total. But in total, the length from D to A is 15 centimetres. 5 isn't 15. We need to therefore multiply 5 by 3 to arrive at 15 centimetres. So if we take these values here and multiply by 3, we therefore get 6 centimetres for DM, and 3 times 3, 9 centimetres for MA. So let's label this on. So from M to A is 9 centimetres. So we can label this on here. And as well as that, we need to work out from M to B. We know the line from A to B is 15 centimetres. So we can now work out MB by using Pythagoras. So MB, this hypotenuse, will be the square root of 9 squared plus 15 squared. So if we calculate this, so the square root of 9 squared plus 15 squared, that gives us 3 root 34. And for now, let's leave it in exact form. So we get 3 root 34. So we now know one side of this triangle. But to work out an angle theta for a right-angled triangle, we need to know at least 2 sides. So we can either work out from M to E, we can work out the length ME, or maybe we could work out the side EB. Now, I did say I'd return to this angle fact here, that angle EAB is 35 degrees. You can see it here. So what I'm going to do now, because this is a prism, I'm just going to take this angle and pop it here so that you can see this triangle a bit more clearly. So this one's 35 degrees. Okay. So we could work out F to C, which will be the same as from E to B. So because this base is a square, if this is 15, this will be 15 centimetres as well. So just considering the triangle DCF, we know DC is 15. We want to work out FC. So let's just call this question mark. And FC, as we can see, that's the side opposite to the 35 degree angle. I'll pop in this as degrees. DF is for hypotenuse, that's the longest side. So we want to know the opposite, and we do know the adjacent. So this here is going to be TOA. FC, which is the opposite. So we cover up the opposite, and we therefore must do T multiplied by A. So considering triangle DCF, the size of the line from F to C is going to be tan 35 multiplied by 15. So let's see what this gives us. So tan of 35, close the bracket off, then multiply by 15, and we get 10.503 and so on. So I'm not going to round this number prematurely. I'm going to leave all of this on the calculator. So 10.503. What else do we have? 11307. So I'm going to rub off the question mark. I'm going to put on this number as it stands. That's 10.503 11307. But most importantly, this is now also the same as from E to B. And so if this is 10.503 and so on, this length from E to B is also going to be 10.503 11307. Now considering the triangle EMB, we now know two sides. We know the adjacent side, which is 3 root 34, which we worked out earlier, that's MB, and we know EB is 10.50 and so on. So now, if I just consider triangle EMB, tan of theta is the opposite over the adjacent, which is 10.503 11307 all over 3 root 34. Now we should recall, to work out an angle with trigonometry, we have to do tan minus 1. So therefore the angle we want, which is theta, remember theta is the angle between EM and the base of a prism, we need to do tan minus 1 of this value. So theta is going to be tan minus 1, 10.503 11307 all over 3 root 34. So what does that give us? Well, I've got this number stored in the calculator, so I'm going to leave this as it is. If I press A and S, I've got it stored. So shift tan minus 1, the answer I've got stored all over 3 root 34. I get 30.98157. If I rounded this to one decimal place, that 9 would actually round up. It would round up from 30.9 to 31.0. So it's important that I include this 0 as well, because that shows it's not just 31 to the nearest degree, it's 0.0. We've done it to the nearest 10th of a degree. So that's question 19 done. Now we can move on to the last question of the entire paper. So here we are, question 20. So it's a vector problem. C, D, E, F we're told is a quadrilateral, and we've got these details. So from C to D is vector A, from D to E is vector B, and from F to C is the vector A minus B. We need to express FE in terms of A and or B, simplifying if we can. So vectors, as I always say, and probably always will say, are almost like roads. Okay, so we can only use roads that we know about. So we need to go from F to E. So how can we do that using the roads we know? Well, to go from F to E, what we could do first of all is we could go from F to C. So first of all, we're going to go from F up to C, because we know that, we're told what FC is, so that's a road we know, we can do that. Then when we're at C, we can go across from C to D. And that's okay. We know how to do that because we're told what CD is. CD is A, just as we were told that FC is A minus B. And then once we've got to D, we can go from D to E. So using this detour, we've gone from F to E by going up and around. So the final thing, once we get to D, is to go from D to E. And again, that's fine. We can do that because we're told what from D to E is. So that's in terms of letter form, for lack of a better word of saying it. We now need from F to C as a vector. So from F to C is vector A. And from C to D, oh, sorry, FC, my mistake. From F to C, I'm sorry, we're told is A minus B. So that's A minus B. Then CD is just simply A. And finally, DE is vector B. So now it's just a case of simplifying this if we can. And of course, actually we can. So grouping together the A terms, we've got A plus another A, which is 2A. And the B terms, minus B plus another B, cancels. So the B's cancel to leave us nothing in terms of B, so we just have 2A. Therefore, F to E is double the vector A. Now, part B is the absolute beast. So we're told here about M being the midpoint of DE. X is a point on FM such that Fx to xm is split in the ratio from n to 1. CXE is a straight line. We need to work out the value n. So I'm actually going to almost ignore this ratio n to 1. I'm going to think of it in terms of two things. And so how could we go from f to x? Well, from f to x lies on the line fm. And as well, we're told that CXE is a straight line, so x is on the line from C to E. So we can add this information in as well, like so. So it's almost hidden now. I'll just go over it again with a bigger point. So that's x. So we can say this in two different ways. So fx is some multiple, I don't know what multiple it is, but it's some multiple of fm. So I'm going to say that fx equals lambda fm. So I'm just going to let this multiple, I've said some multiple, that multiple I'm just going to say is lambda. Okay? So it's lambda lots of fm. So we can work out what this is in a bit more depth. So how can I go from f to m? Well, I can go from f all the way to m by going fc, then from c to d, and then d to m. But we're told that m is the midpoint of DE, and so m is half of DE. So I'll add this in here. From D to M is just half of the way from D to E. So let's now go from letter form to vector form. So from F to C, that's A minus B. From C to D, we're told that's vector A. And then from D to E is B. So half of DE is just half of B. So finally simplify out some of the brackets. A plus A is 2A. And minus B plus half of B is still minus half of B overall. And so that's what fx is. From f to x, it's some multiple of fm. Now that's one way we could go from f to x. Okay, so I'm just going to pop a pin under this here. So from f to x is some multiple lambda of this. However, we could also go from f to x by going from f to c, then from c to x. And again, x is somewhere along the line from c to e. So just as I said that fx is some multiple of fm, I can also say here that cx is some multiple of the total distance from C to E. So some multiple of CE. I can call this multiple, say, mu. So I'm going to say that Cx is mu lots of CE, where mu is just a Greek symbol. I could have used a different letter, but this mu just means some multiple. I'm not sure what the value of this multiple is yet. So based on this one here, I can say that fx equals fc plus mu lots of cx. So what I need to do here is get it from this lettered form into a vector form. So from f up to c, that's a minus b. Then plus mu lots of from c to x. Sorry, from C to E. That's another mistake. I think I must be tired. Do apologise. That should be CE. So how do I go from C to E? Well, from C to E, there's a few ways I could do this. What I'm going to suggest is I can go from C to D. From C to D is A. Then I can go from D to E. From D to E, DE is B. And so, as you can see, I now have two different expressions for how I can go from f to x. So one route from f to x direct, I've got this, or going from f to c, then from c to x, I've got this expression here. What I can now do is say, because both these are equal to fx, I can equate these two expressions I've highlighted in blue. So I can now say, therefore, lambda lots of 2a minus a half b equals a minus b plus mu lots of a plus b. So all I've done here, because both of these are equal to fx, I've said that one must be equal to the other. Now we can compare the terms in A and B here and get something out of it. So over here, I'm going to factorise out the A. If I were to expand out these brackets, I'd have A multiplied by 2 multiplied by lambda. So over here I have 2 lambda, lots of A. And in terms of the B terms, I've got over here plus minus a half lambda, lots of B. Expanding this out, I'd have A plus mu A. So I've got 1A plus mu A. So 1 plus mu, lots of A. And for B's, I've got mu B here. So mu lots of B minus 1 lot of B. So mu lots of B minus 1 lot of B. So because one side is equal to the other, the stuff in terms of the lambda, the A stuff, this 2 lambda must be the same as this A stuff. The coefficient of A over here must be the same as the coefficient of A over here too. And as well as that, for B stuff, this minus half lambda must equal this over here. So from this, we can form 2 equations. So 2 lambda equals 1 plus mu, and minus half lambda equals mu minus 1. So what I'm going to do here, I want to eliminate this lambda, or eliminate one or the other really, doesn't really matter, but I need to solve one of these equations simultaneously, so I need to either eliminate the lambda or mu. There's a few ways of doing this. What I'm going to do here is I'm going to multiply this bottom equation by 4. So if I multiply all of this by 4, I get minus 2 lambda equals 4 mu minus 4. I'm going to leave the top one as it is. 2 lambda equals 1 plus mu. I can now add these equations together. And if I do that, 2 lambda plus minus 2 lambda, that's going to cancel. So I get 0. 4 mu plus an extra mu is 5 mu. 1 plus minus 4 is minus 3. I can then rearrange this by adding 3 to both sides and dividing by 5. So therefore mu equals 3/5. However, I'm interested here in what multiple of fm is, what multiple of fx is, I mean. So that multiple of fx, we define this, if we just remember and scroll up, we define that as lambda. So if lambda was a half, that would mean x is halfway along. If lambda was 2/3, that tells us that x is 2/3 the way up from f to m. So we're interested really in this lambda. So now we know that mu is 3/5, we can now sub mu equals 3/5 into either one of these equations. I'm going to pick the red. So we get now that 2 lambda equals 1 plus 3/5. That gives us 8/5. So now if we divide that by 2, lambda equals 8/5 divided by 2, and if we try that, if you're not sure, 8/5 divided by 2 equals 4/5. So that tells us that x is 4/5 the way up from f to m. So therefore, fx to xm, fx is 4/5 the way along, so xm, this tiny piece here, must be 1/5. However, we need this ratio in the form n to 1. So we don't want a fraction, we want these as whole numbers. So what we need to do here is to multiply both sides by 5. 4/5 times 5 is 4. 1/5 times 5 is 1. So fx to xm is 4 to 1. So in other words, fx to xm, because it's n to 1, n must be 4. So therefore, n equals 4. That was a nightmare of a question. That is definitely, I would say in my opinion, a grade 9 every single day. If you can do that, there's very little to fear. You can do pretty much anything, I think, to be honest. Anyway, that's all there is from me. That's the paper finished. Thank you very much for listening. I hope you found it useful. Do leave me some feedback in the comments. Keep it clean, please. And please remember to subscribe. So thanks very much again, and I'll see you all perhaps very soon. Bye for now.